All right, today we're diving into something really special. It's a project that smashes together real-time computing, crazy sustainable materials, and some seriously advanced wireless tech, all to completely reimagine what a musical instrument can even be.
Yeah, I know what you're thinking, but as you're about to see, this is so much more than an instrument for making music. This is being presented as a blueprint for the future, a whole new way of designing smart, integrated, and frankly responsible devices right from the ground up. So let's take a quick peek under the hood, shall we? We are talking about a custom digital brain written in the super safe Rust language. Its body is made from a carbon negative composite, and yes, that means it actually removes CO2 from the atmosphere. And on top of that, it's got some incredibly clever hardware for connectivity and control. Any one of these pieces would be fascinating on its own, but when you put them all together, you get something truly revolutionary. To really get what makes this project tick, we have to start at its very core, the central nervous system, or what the engineers call the kernel. This is where all the real magic is happening. So what even is a real-time kernel? Well, think of it like a hyper-disciplined traffic cop for data. See, unlike your laptop's OS, which might lag or stutter sometimes, a real-time system guarantees that a task, like processing the sound from a guitar string, happens within a fixed, incredibly tiny window of time. For music, where a delay of even a few milliseconds is totally noticeable, that kind of precision is it's absolutely non-negotiable. The technology choices here are super smart. The developers went with Rust, a language that's famous for preventing all those common, annoying software bugs. And they built it for RISC-V, which is an open-source, totally customizable processor architecture. That combination gives them just maximum performance and safety, with dedicated software modules for all the critical stuff like audio processing and wireless connectivity. Okay, so we've talked about the brains of the operation. Now let's talk about the body, because the innovation definitely doesn't stop with the software. This project takes a pretty radical approach to the actual materials and hardware that make up the guitar itself. So on the one hand, you've got your traditional wood. It's got that classic tone, sure, but we all know the downsides, the environmental impact, the warping, and then on the other hand, you have the project's choice, a hempcrete composite. This stuff isn't just sustainable, it's also incredibly tough against fire and moisture, and it opens up a whole new world of acoustic possibilities. And this number, this just says it all. This is the environmental win. This number represents how much CO2 is sequestered or literally pulled from the atmosphere by just 1 cubic meter of this hempcrete material. This means the guitar's body is actually carbon negative. It's not just neutral, it actively helps the environment. It's just wow. So, how does the smart guitar talk to the rest of the world? Not with some clunky, off-the-shelf antenna sticking out of it. Nope. It uses this, a Sierpinski fractal antenna, and it's integrated right into the headstock. Just think of it like a Swiss Army knife for radio waves. Its complex, repeating pattern lets it handle both Bluetooth and Wi-Fi signals super efficiently, all in a tiny, hidden space. Okay, so we've got a digital brain and a futuristic body. But how does a musician actually, play it? How do you control all that complex tech in the middle of a performance? Well, let's take a look at the interface. The design docs actually looked at 3 different options, and this table lays out the trade-offs perfectly. A touchscreen? Cool, but it's got high latency and drains the battery. A purely wireless app is even more flexible, but there's zero tactile feedback. But then look at good old buttons and switches. Basically zero latency, great tactile feedback, and they're incredibly durable. For a musician, that stuff is gold. So they didn't just pick one. They did the smart thing and went with a hybrid solution that gives you the best of both worlds. You get physical knobs for instant, no-thought-required control over things like volume and effects. And then you use a wireless app for the deeper stuff, like loading new digital signal processing programs before a show. It's genius. Okay, now this is where we really zoom out, because as awesome as a smart guitar is, the technology they developed for it is so powerful and flexible that its applications go way, way beyond the stage. This thing is a platform. Of course, the main use case is audio. This system can run real-time effects that could blow professional pedals out of the water. It can generate totally new sounds through synthesis, and it can even do advanced noise cancellation, all with the ability to get new updates wirelessly. But what about in the world of science? Well, this platform becomes a portable, high-precision instrument. You could use it to analyze animal calls out in the wild, study material vibrations in a lab, or even process biological signals like heartbeats in real time. And in robotics, the kernel and audio hardware could basically become the ears for a machine. This would let a robot understand voice commands, figure out where a sound is coming from, and react to its auditory environment. Pretty cool, right? And finally, in the Internet of Things, this tech allows for something called edge processing. All that really means is that devices like smart assistants or security sensors can process audio right there, on the device itself, without having to send your data to the cloud. That makes them faster, more responsive, and a whole lot more private. So after seeing all of this, the kernel, the body, the controls, and all the crazy applications, what's the big takeaway here? What does it all mean? Well, the project is way more than just the sum of its very impressive parts. At the end of the day, this project is a blueprint. It's a proof of concept for a whole new way of thinking about product design, one where high-performance software, environmentally positive materials, and multi-purpose hardware aren't just afterthoughts. They're woven together from the very beginning. And the project's documentation makes it crystal clear that this isn't just some academic thought experiment. This is proprietary, cutting-edge R&D, which means we're getting a rare behind-the-scenes peek at what the next generation of technology could really look like. Which leaves us with one last big question to think about. This whole thing started with a guitar, but its principles could apply to almost anything. So what would the world look like if every single device we designed was built with this level of intelligence, sustainability, and versatility right from its very inception? Just imagine that.